they give a good explanation of how the carboxylate anion of benzoic acid is involved in resonance. So the negative charge on the oxygen cannot be delocalized, but you will see that it can donate its the conjugate system benzene இருக்கிற conjugated system இருக்கு இல்லையா, அது வந்து it can donate a pi electron to the carbon and can accept a positive charge, and you see that how this is revolving, the positive charge revolving around the benzene ring, you will see. ஸோ இது வந்து இன்னொரு ரெசனன்ஸ் ஸ்ட்ரக்சர்ஸ்க்கான நிறைய ரெசனன்ஸ் ஹைப்ரிட் எப்படி ரெசனன்ஸ் ஸ்ட்ரக்சர் எப்படி எழுதணும் அப்படின்றத இதில் நான் ஒரு கொஷின் வந்து இஸ் அபவுட் அதை கண்டினியூயிங் இதோட ரெசனன்ஸ் ஸ்ட்ரக்சர் வரையணும், 4ஓட ரெசனன்ஸ் ஸ்ட்ரக்சர் வரையணும். ஸோ அதை வந்து நான் உங்களுக்கு தெரிகிற மாதிரி நான் ஃபஸ்ட் அட்ஜஸ்ட் பண்ணி எழுதுறேன். ஓகே, ஸோ 4th-ஓட ரெசனன்ஸ் ஸ்ட்ரக்சர். Okay, so let me draw the structure. So this is this one. Okay, so that structure is CH2 positive charge, okay, so idoda resonance structure varai solukam. Okay, draw all possible resonance structure. So let me draw this. So inna paakalam, so there is a positive charge and there is a pi bond here. So all we have to do is just move this pi bond here, just move this pi bond here, and you will get a positive charge on this carbon, and a double bond is moved to this carbon. So this is the resonance structure possible. இதை தவிர்த்து வேற எதுவும் முக்கியமான resonance structure எதுவுமே it's not possible for resonance structure for this. Okay, so I'm going to draw that CH2 plus okay, so the resonance structure பார்க்கலாம் வரைய முடியுமா. If you look at this, நீங்க பாத்தீங்கன்னா இங்க வந்து ஒரு சிங்கிள் பாண்ட் இருந்துச்சு, அப்புறம் டபுள் பாண்ட் இருக்கு. ஆனா இந்த சிஸ்டம்ல ஒரு சிங்கிள் பாண்ட் இன்னொரு சிங்கிள் பாண்ட் இருக்கு. ஸோ it's not possible to draw any resonance structure. No resonance is possible. There is no resonance because இதை வந்து மூவ் பண்றது, so electron cannot move to delocalize this positive charge. அது வந்து பண்றதுக்கு வந்து வாய்ப்பே கிடையாது. ஓகே, சரி, நெக்ஸ்ட் ஸ்ட்ரக்சர். ஸோ நெக்ஸ்ட் நான் வந்து இது பார்க்க போகிறோம். நெக்ஸ்ட் ஸ்ட்ரக்சர் இஸ் திஸ். So what is the structure? That one CH2 plus okay, now if you look at this structure, you will see that so the first thing that you can see is you can move this here. Okay, you can move this pi electrons here, so you'll get a structure which is like this. So there is a positive charge here, so obviously you will get a positive charge here also. Okay, very good. And another structure that is possible is this can be moved here. This electron, these pi electrons can be moved to this carbon-carbon bond, this carbon-carbon bond, and you will have this structure. So these are the all possible resonance structure. Fine. Possible resonance structure for this. Draw all possible resonance structure for the structure. So you can see that this is a phenyl ring. So obviously you will have you can move these pi electrons and the positive charge can be delocalized over the entire ring. Okay, so everywhere this one I am drawing this probably for the 4th or 3rd time, but anyway I'll draw this. So என்ன நடந்திருக்கீங்க, it has moved here and you will get a positive charge here because this carbon has lost both its electron. Okay, has lost one of its electron. So you will get a, okay, now what happens, this will go here and this positive charge will come here. So there is a CH2 here. Now again this will come here and the positive charge should develop here. CH2 so these are the 4 resonance structure that is possible for. So this is a very important cation called as the benzyl it's called benzyl carbocation. Okay, it's called benzocarbocation. So it's very stable structure. இது நீங்க வந்து அடிக்கடி உங்களோட ஆர்கானிக் கெமிஸ்ட்ரி கோர்ஸ்ல பாப்பீங்க. பென்சைல், ஓகே, பென்சைல் கார்போகேட்டன். ஓகே, கேள்வியில the following representation is are incorrect. Why? இது வந்து incorrect னு சொல்றாங்க. இந்த ரெண்டு ஸ்ட்ரக்சரையும் பார்த்தா it is incorrect னு சொல்றாங்க. So ஏன் ரீசன் என்ன அப்படினு கேக்குறாங்க. So that's the question. Why these are incorrect? So first என்னது சொல்றாங்க. So this is the structure. Let's first draw the structure. So the structure, sorry, it should be like this. So the reason is sigma bond break பண்ண முடியாது. You cannot break sigma bond. Okay, so sigma bond is broken, which is not very ideal for resonance. Sigma bond is broken. So this does not represent the correct resonance structure. Good. Next problem. Okay, so this is, so the question is why this structure, let's say label that 1 and 2, why 2 is not, so ஏன் வந்து இது வந்து 2 வந்து resonance structure கிடையாது 1 க்கு, why 2 is not a resonance structure of 1. The following representations are incorrect. Why? So why it is incorrect? The thing is, if you move electron here, okay, you இங்க பாருங்க, இப்போ நம்ம வந்து என்ன பண்ணிருக்காங்க, what they have done, they have just moved one electron, pi electrons to here, and this they have moved it here, which is not correct. First thing on the, when you move pi electrons here, obviously you will get a positive charge. இங்க move பண்ணா you will get a positive charge. Okay, you move panna, you will get a positive charge. Okay, if you move panna, you will get a positive. But this cannot move here. This cannot move here. This has to go to this atom. So this structure is allowed. But this pi electron moving to the neighboring is not correct. Okay, sorry, this structure is allowed. ஓகே, ஏன்னா நீங்கள் இப்படி போட்டிங்க அப்படின்னா இப்போ இதில் இருந்து நம்ம இதை வந்து இப்படியே மூவ் பண்ணுற மாதிரி வச்சுக்கலாம். ஓகே, இதை இப்படி மூவ் பண்ணுற மாதிரி வச்சுக்கிட்டா கூட இதை வரைஞ்சி நான் காட்டுறேன். ஓகே, ஸோ ஐ ஜஸ்ட் ஷோ யூ how the system. So if you move it here and let's say you move it here. Okay, so what will happen now? Let's assume, so you will have a positive charge here and you will have this here and you will have this here. But we have seen that here the charge is Here the charge is 0. What happened to here? Here the charge will be plus 1. So these two are not allowed. Overall the charge is 0. So overall this is a correct resonance factor. This is the correct. So you can notice that here what they are doing, they are moving pi electrons from here to here, and then this pi electron is going here. Okay, so this is not a valid structure because oxygen, when you move pi electrons here, okay, pi electrons in the arrow work, when you move pi electrons here, it cannot get a negative charge. It has to get a positive charge. Adhe madri, when you move electrons here, okay, so this is gaining 2 electrons here. Okay, so this is gaining an electron here, so it cannot be minus 1, but it has to be minus 2 or something. Okay, so that's why this is not allowed. This is not allowed, because if you move electrons from this carbon oxygen bond, this should get a positive charge, which is not allowed. The correct structure that can be written for this is this one. So the correct structure that one can write is this one. The negative charge will go into the molecule. So this will form a double bond. This can go here, and then this can go here, and so you can have a resonance structure which is like this. This is possible. This is possible. This is the correct. So this is possible, but not this one. Because you are moving electrons here to this single bond, that means this will lose a electron, oxygen will lose an electron, so it should gain a positive charge, not a negative charge. So this is not correct. They are moving the pi electrons from here, and they are getting this. So they are asking why it is wrong. The reason is very simple. The same reason. Pi electron இங்கிருந்து இங்கே போகாது, இங்கே போச்சுன்னா இங்கே ப்ளஸ் சார்ஜ் வரும். ஓகே, இங்கே ப்ளஸ் சார்ஜ் வரும். ஸோ த கரெக்டாக இவங்க போட்டிருக்க மாதிரி எலக்ட்ரான் போட்டால் எப்படி வரணும் அப்படின்னா, யூ வில் கெட் சம்திங் லைக் பாசிட்டிவ் சார்ஜ் ஹியர், யூ வில் கெட் அ மீத்தேல் குரூப் ஹியர், யூ வில் கெட் திஸ் ஹியர், அண்ட் யூ வில் கெட் ஹைட்ரஜன் ஹியர், and this should get a negative charge. So this is okay, but the way they have written this one is wrong, because when you move electrons from this pi bond to here, this will lose one electron, so it will get a positive charge. So so that is what is right. But ideally in the molecule pathina, the ideal structure is slightly different. Okay, so which is not which I will just tell you. So in the molecule pathina, if you write something like CH3 H, okay. So because oxygen is more electronegative, it will like to take this pi electron to itself, and the lone pair on nitrogen will go to this CN bond, and you will have a structure which is like this. Okay, so always remember, if we stick put that means it is assumed that there is a methyl group here. That means it is assumed that there is a methyl group here. Methyl group CH3 irukku appdi nartham. So this is allowed. This is a valid structure.